So now we will discuss in this session multi-objective optimization. So it is little bit advanced area in operation research, but now many of the publication have already been done. So it is not so important. It is just like linear program. So we try to include this session in this course. So I start. So I want to interact with the participant at different nodal centers. So प्लीज एक जयपुर इंजीनियरिंग जो है कॉलेज उसको कनेक्ट करिए. Hi, yes, good morning.
Yes, sir. Good morning, sir.
Yes, where are your participants?
So they are just coming.
They are coming.
Actually, today they are late.
Huh? Okay. So we are also late, but you call the participants. They attend this session. It is very important session.
Yes, sir. Yes, sir.
And yes, yesterday we have some connectivity issue.
Yes, sir.
So we could not connect you. So at least in today, you all participants be present in the sessions.
Yes, sir. Definitely. Yes, sir. Blog.
एक और को कनेक्ट करिए, पानीपत. Yes, good morning. This is Panipat Institute. Okay. हाँ, उनसे कनेक्ट करिए.
Yes, at Indira Gandhi University.
At Indira Gandhi University for Women.
माइक ऑन कर लीजिए सर अपना.
Your voice is not audible.
Hello.
Hi, yes. Good morning.
Yes. Good morning, sir.
Good morning. So, where are your participants?
Sir, they are coming.
They are coming. Okay. So now we are starting the session on multi-objective programming problems. As well as we will also try to deliver simplex method for linear programming. So I request all the participants to be present today because yesterday we have a connectivity issue. So
Yes,
I hope that you all participants be present fully in today.
Sure, sir. Thank you, sir.
So now I start on multi-objective optimization. Multi-objective optimization is part of multi-criteria optimization. Basically, multi-criteria optimization is a broad area where multi-objective, multi-level programming problems are delivered. So in this session, we will focus on multi-objective optimization. So it is a part of mathematical programming problem. Yesterday we had talked on linear programming. Day before yesterday we had talked on linear programming, where one objective function is there and set of constraint was there, right? So only one objective function was there. If there are more than one objective function, then that type of situation is called the multi-objective programming problems. Multi-criteria optimization is slightly broad area where multi-level, multi-channel optimization problems, multi-objective optimization problems are discussed. But we try to focus on multi-objective programming problems, right? Multi-objective programming problem means when a linear programming problem has more than one objective functions. Yes, शुरुआत में अपन ने पढ़ा था LPP means one objective function, set of constraint and non-negativity restriction. For example, at the same time we have more than one objective functions, then that type of problem is called the multi-objective. मान लीजिए आपने कहा कि मेरा प्रॉफिट, एक प्रॉब्लम आपने डिस्कस की थी, I want to maximize my profit. Also, I want to minimize my cost. So we have two objective functions. One is to maximize the profit and the second is I want to minimize the cost. So that type of situation is called the multi-objective programming problems. So it is a part of mathematical program problem where we can formulate a multi-objective programming problem as a mathematical format. Now we come to the operation research. It is a part of operation research or optimization techniques because operation optimization starts from operation research. Operation research is a broad area where optimization techniques are delivered, mathematical programming problems are there. So operation research is an interdisciplinary area. Nowadays operation research are taught to mechanical engineers. Optimization techniques is taught to electronics engineering and electrical engineering. In research level, civil engineering, they are also taught the operation research optimization techniques. In mathematics, because there is a use of mathematics, mathematics people are also working in operation research. It is a new area. It was started during the Second World War. So it is interdisciplinary area. Nowadays, each and every field they are using the optimization or operation research techniques, right? So operation research, like all scientific research, is based on scientific methodology which involve formulation of problem, deriving solution from the model and establishing control over the solution and putting solution to the work. So basic characteristic of this subject is that you have individual problem, you just formulate the model of that problem, then construct the mathematical formulation, find the solution and then put the solution in the work, right? For example, a mechanical engineering working on some material, some shaft or some different type of situation. He has some problem, he want to optimize the things. He will first formulate a mathematical model. Then he or she will find the solution, and then solution is established to the practical situation. That is the methodology of operation research. अब वो traditional चीजें खत्म हो गई कि only dy by dx will be used, right? Now there are so many complex problems are there where individual problem has individual solution. Earlier we have a general solution that differentiation will be used, but nowadays problems are so complex that we need individual solution to individual problem. So that is the methodology of operation research. So this involves the formulation of problem, then constructing a model, third deriving a solution from the model, establishing the control over the solution. Some parameters is being used. By using that parameter, you can control the solutions, and then putting solution to work. These models are formulated in mathematical format, which has objective function, set of constraint, and decision variables. जैसा कि पहले अपन ने LPP में पढ़ा था, this type of mathematical formulation has objective function, which is to be maximized or minimized or optimized, set of constraint, and non-negativity restriction. So there are so many mathematical programming models are there. We cannot say it is only LPP or fractional programming or multi-objective. So we have some examples of that. Then we come to the multi-objective. First and simple form problem is linear programming problem. So starting day we have discussion on LPP, how we formulate, how we solve by graphical method. Then it is linear fractional programming problem. It means either your objective function or any of the constants is in fractional form. Then it is a linear fractional programming problem. If your objective function is in numerator upon denominator form, then it is called the linear fractional program. Right? Linear means it is a linear relationship. Linear fractional means you have numerator and denominator format. Then multi-objective linear programming problems. It means we have more than one objective functions. At the same time, linear programming will have single objective function, but in multi-objective programming problem we have more than one objective functions with set of constants. Then multi-objective linear fractional programming problems means it has more than one objective function, but objective functions are in linear fractional format. Linear fractional format means numerator upon denominator format. So you can classify for each and every problem. You have a different methodology, you have different theory. You cannot apply the theory of LPP into linear programming into non-linear programming, because linear programming is changed, your feasible region will be changed. If you are taking non-linear programming, जो आपका region बनाया था आपने graph में, it will be changed, and now your optimal solution will not lie on the corners. So each and every problem you have a different theory, as well as different theorems are there, different techniques are there, different tools we use as a software. You cannot apply the same theory, same methods to each and every problem. Then multi-objective linear plus linear fractional. Linear plus linear fractional means objective functions are in the format of linear plus one fractional function. Linear function is there as well as fractional function.
How जी आओ?
Then it is, but we can convert this problem into either linear programming problem or non-linear programming problem. That we can do. Right? Then multi-objective non-linear programming problem. If your either objective function or any of the constant is in non-linear format, then it is called multi-objective non-linear programming. At the same time, for non-linear programming problem with single objective, theory of single objective functions with non-linear programming problem will not apply for the multi-objective, because now we have more than one objective functions which are non-linear. So you have to tool different techniques like fuzzy techniques, goal programming, particle swarm. Basically these are the searching how we find the optimal solution, best solutions. Then multi-objective quadratic programming problem. It is a part of non-linear programming problem when your functions are in quadratic format. Quadratic format means your the product of two linear functions is quadratic. So we have some example, then it will be clear what is the quadratic. It is a non-linear programming problem basically, and quadratic function means the product of two linear functions. Okay. Then multi-level programming problems. Multi-level programming problems is another different programming problems. Multi-level means there are hierarchy, first level and second level. अगर इसको अपन सिंपल भाषा में बात करें तो दो तरह के चेन है, सेंट्रल गवर्नमेंट एंड स्टेट गवर्नमेंट. The working of people are at bottom level, but they have to work in the periphery of central government. So central governments के region में, central governments की conditions में second level state government को work करना पड़ता है. This is case of bi level. Two levels are there. एक घर में भी अगर बात करते हैं तो सबसे बुजुर्ग होते हैं फर्स्ट लेवल पे, सेकंड लेवल पे आपके जो बड़े हैं वो थर्ड लेवल पे आप. So it is a tri level. So they have connections. They are interrelated. Their objective functions are interrelated. Their constraint may be different, right? Their objective may be different, but you cannot go beyond their limitations. So you have to work in that periphery. So that type of problem is called the hierarchical programming problems or multi-level programming problems. So there are so many different type of programming problems are there. So we will restrict ourselves for multi-objective only. We will not describe the bi-level and multi-level programming problems. So multi-level non-linear programming problems. Further, even multi-level programming problems can be further classified in different ways. For example, multi-level linear programming problems, where there are more than one levels are there, but all the objective functions are linear and their constants are also linear. So this is called multi-level linear programming problem. Second is multi-level linear fractional programming. Again, multi-level structure is there, first level, second level, third level, and objective functions are in linear. Then objective functions are linear fractional format, numerator upon denominator format. So it will become more complex. Now the question is how you will find a satisfactory solution. We cannot say we will find the optimal solution, because in that situation to find an optimal solution is a very difficult task, right? आज अगर मान लीजिए तीन जनरेशन है, मान लीजिए सेंट्रल गवर्नमेंट, स्टेट गवर्नमेंट, देन यू आर वर्किंग, so it is because there is a conflict of interest, they have constants, so it is very difficult to find the solution which will optimize your first level also, second level also, and third level also. It is very difficult. So in that case we will find the satisfactory solution. Again, if objective function or constants are in fractional format, then it becomes more difficult. Right? Then we can further classify this problem, multi-level linear plus linear fractional programming problem. Again, if objective function are in the format of linear plus linear fractional. Multi-level, now we have more complex structure is there. Multi-level, multi-objective non-linear programming problems. It means we have more than one levels. First level, second level, third level. Again, at the different level, we have multiple objective functions. Now, how you will satisfy each and every objective function, how you will find the maximum solution or optimum solution for every objective function at every level. It's very difficult. ठीक है? घर में अगर अपन बात करें तो एक टॉप लेवल की बात करें तो सास की और बहू की दोनों के इंटरेस्ट अलग होते हैं, तो उसमें भी कंफ्लिक्ट काफी होता है, तो सेटिस्फैक्टरी सॉल्यूशन ही फाइंड आउट किया जा सकता है. और उसमें भी अगर मल्टीपल ऑब्जेक्टिव्स हों तो इट इज वेरी डिफिकल्ट टू फाइंड द ऑप्टिमल सॉल्यूशन. सो वी विल यूज ओनली satisfactory solutions in that case. But then multi-level, multi-objective linear programming. So if objective functions are in linear format, then it is called multi-level, multi-objective linear. Then multi-level, multi-objective linear fractional programming, where objective functions are in numerator upon denominator format. Then multi-level, multi-objective, linear plus linear fractional. These are extension problem basically. The first problem is multi-level, then multi-level, multi-objective, multi-level, multi-objective, linear, linear fractional, linear, linear plus fractional. So these are extension problem, but they have different characteristics. They have different theories. They have different techniques to deal with them. Now we start from LPP. LPP consists of three components. One is decision variable, that is known as activity of the form, and objective, that is your goal or target which we set, and third is the constant, which are limitations or restrictions. So three major parts of LPP is there, and we have talked on LPP, how we formulate that LPP. So this is the your general format of LPP. In this format, we have maximize or minimize Z C1 x1 plus C2 x2. This is the objective function. Subject to, this is the set of constants. We have taken m number of constants. M number of constants we are having, and all variables are non-negative. So this is called non-negativity restrictions, where Cj and B1, B2 are your parameters. It is called the cost elements, and these are the requirement element. And now the problem of determining the decision variable which optimize A, satisfies B and C is called general linear programming problem. Now the problem of determining the optimal solution of that problem is called the LPP. This is a general format of LPP. And you can see where objective function is linear. All constants are in linear format. So this is called the LPP. Right? This is the matrix notation of LPP. And if we make them in matrix format, so Z becomes C transpose X, it is objective function. A X less than equals to greater than B, and X is greater than 0. So you can convert this into matrix format. For example, this is C1 X1 plus C2 X2. If we take row matrix C1, C2, C3 and up to Cn, then multiplied by a column matrix X1, X2, X3. So by the product of that two, we will have this objective function. So the matrix of C1, C2 up to Cn is called capital C, and your row column matrix, it is X1, X2, it is called the decision vector matrix X. So you can convert this into matrix format. So we have taken C transpose, right? C, then subject to constant. Similarly, the coefficient matrix we can take A11, A12, A1n. It is A part multiplied by X. It is column matrix. And B1, B2, Bn. It is your just like a requirement matrix B. It is your column matrix. So you can convert this into matrix notation. Convert कर सकते हैं. I don't think there is a problem to convert into matrix form. So now we come to the further linear fractional programming problem. Yes, this is the matrix format of LPP, linear fractional programming problem. You can see a linear fractional programming problem can be described by maximized. It is Z C transpose X plus DTX. This is in fractional format, and this is set of constant. This set of constant may be in less than sign, equal to sign, or greater than sign. It is not necessary always be equal sign or less than, maybe greater than sign may be there. So this is the set of constant, and X is the non-negativity restriction. X is your vector, decision variable vector, and it is greater than equals to 0 means each and every element of this matrix is greater than 0. It means X1 is greater than 0, X2 is greater than 0 up to Xn is greater than 0. So this is mathematical formulation of linear fractional programming. So now it becomes more difficult. Yeah, these are the standard form. Yes. So here we assume that in the feasible region your denominator is always positive within the feasible solution. Otherwise, if this becomes 0, your objective function become infinite. So in order to define this problem, we must have assumption that denominator is positive, so that we can find an optimal solution or a finite solution, right? So A is a matrix. A is this matrix. It is called coefficient matrix. X is variable matrix. B is requirement matrix. C is a cost matrix in numerator. D is a cost matrix in denominator. And it is assumed that the denominator is positive within the feasible region. Yani ki if you plot this region, it must be positive. Denominator part of objective function must be positive. So this is a general format of linear fractional programming. Linear programming, it is okay. You can formulate the problem, find the solutions. You can use the simplex method. For linear fractional programming, either you convert this problem in LPP, or you have to develop different methodology to solve this problem. Right? So any questions, any query? Any questions regarding linear fractional programming?
No, sir. Hello?
Yes.
Sir, from SIM, no problem, sir.
हाँ. नो प्रॉब्लम. नहीं, इन्होंने कहा था वो उनको करेक्ट करिए, एक जो बैठे हैं. हायर्स. Highest, any query, any questions regarding multi-objective or linear fractional programming problem?
No, sir.
इनसे पूछिए जो अभी बैठे थे, कनेक्ट करिए. Okay. Now I want to ask them. Any question or any query from Jaipur?
No, sir. Thank you.
Okay. Now we start the multiple objective. These are the basics of linear and linear fractional programming problems. So multi-objective linear programming problems.
Hello.
Yes.
Good morning, sir.
Yes. Good morning.
Sir, I have some questions.
Yeah. Please.
Yesterday you discussed simplex method.
Yeah.
When the constraints are of less than type.
Huh?
When the constraints are of less than type.
Yes.
When the constraints are of equality types or greater than equal to type, so we can also apply big M method and two-phase method.
Yes.
Hello.
Yes. You can apply two-phase method and big M method. I agreed. Then,
sir, I want to know ki out of the three methods, one is simplex method, big M method, and two-phase method. Which is the best one method, sir?
See, simplex method is a method, and big M and two-phase method are part of simplex method. They are not individual method. See, simplex method is the only method, and big M and two-phase method are part of that method. When your artificial variable is involved, then we can use the two-phase method either or big M method. So these are the part of simplex method. Simplex method is the only method.
Okay. And what about the penalty method? We also apply the penalty method.
Big M method.
Okay. Thank you, sir.
Okay. So now we come to the multi-objective programming problems. So multi-objective linear programming problem seeks to optimize more than one conflicting objective functions of the form. It is important that the objective function must be conflicting, just opposite, or it should not be similar type. आपने लिख दिया Z, first objective function is x1 plus x2, second objective function is 2x1 plus 2x2. So this is not the multiple objective programming problems. So we have to optimize more than one objective function. For example, first fx is zix and I is equal to 1 to k, and where fi are linear functions subject to linear constant under the assumption that the set of feasible solution is a convex polyhedron with a finite number of extreme points. So here we assume that you have multiple objective functions, and your feasible region must have a polyhedral with finite number of extreme points, so that we can calculate the maximum value of each and every individual objective function at that corners. So here is also assumptions that your feasible region must be a bounded region with finite number of extreme points, so that you can calculate the maximum and minimum value of each and every objective function at that points. So this is the format. You can see mathematically multi-objective linear programming problem can be formulated max, mini, Z1, Z2 and Zk. All objective function are conflicting. They are just not similar type. Otherwise we can if they are similar, then it can be converted into a linear programming with single objective functions. So all the objective function must be of different kind of conflicting in nature. Then subject to some set of constant, we have constant ax less than equals to b, x is greater than equals to 0. So this is the set of constants, and where each and every objective function is in linear form, Cix, and your other notation have usual meaning. A is the coefficient matrix, B is requirement matrix, X is greater than equals to 0, that is non-negativity restriction. S should not be 5, it means your set of feasible region should not be an empty set, it should be have some points. So this is the general format of multi-objective programming problem. More and more people are working on that, especially the mathematics person has developed so many techniques. Now the engineering people are using the multi-objective programming problem for their own research work. Right. So it is better technique, better programming where you can use in your research work. You have different type of problems where you can formulate that problem in multiple objectives, programming problems. Because in practice, in real world, there are many problems which have more than one objective functions. So you can use that techniques directly. So then in that case, your paper may be published in good journals. R belongs to, this is your B belongs to your Euclidean space, that is a mathematical term. So it has m number of elements. Right? For example, Rn belongs to x1, x2 up to xn, that is called n Euclidean space. Similarly, we define B belongs to Rm, means it has m number of elements, B1, B2 up to Bm. Right? So we have all total k number of objective functions. This is the general format of multi-objective programming problems. You cannot say ki directly we are finding. Now use your IQ how you will find the solution which maximize or optimize each and every objective function. So it is very difficult to find an optimal solution in that case. In that case, we use the word satisfactory solution, which is somehow optimal to some of objective functions, or compromise optimal solution is another word. We also use the Pareto optimal solution, that is a definition related to the multiple objective. So this is the mathematical formulation of multi-objective programming problems. It can be seen that multi-objective programming problem is just like a single objective programming problem, except that it has a stack of objective function instead of only one. It has a bunch of objective functions, conflicting objective function. Rest of the things are similar to the LP. Even objective functions are also linear functions. Right? So that type of problem is called the multi-objective programming problems or multi-objective optimization problems. Now because we want to optimize the objective function, so this type of problem is also a part of optimization problems. Right?
So suppose any objective function may be maximizing or may be minimizing. It is a combination of maximizing and minimizing. Or combination of all maximizing or all minimizing. So any choice may be there.
Yeah. Either some of the functions are of maximization and some of the functions are of minimization. So it is also a multiple objective program. You can convert a minimization problem into maximization problem by just multiplying them with -1. Right? If you want to minimize the cost, you just multiply them with -1. So it means you want to maximize the -1 into cost. So it can be converted into a unique form, that is maximization. Right? Any questions regarding this so that we go further? Yes, any question, any query from participant at different order centers? Any question? Yes, your voice is not audible.
Which method is used in solving such type of problems? Such problems.
Which method is used to solve?
This type of problems.
See, there are different approaches. See, that is the goal programming approach, is the traditional approach. Then fuzzy approach is being used. Nowadays, people are using the evolutionary techniques like genetical algorithm, particle sum optimization for solving the multiple objective programming problem. So there are many approaches. New and new research work is going on. So different approaches are being applied to find the satisfactory solution of this multi-objective programming problems.
Sir, I have one question. In this type of problem or objective, there are more than two functions. At a time, we are minimizing or maximizing particular functions, or overall we have minimized or maximized the total function.
See, you have to minimize both the functions. You have to maximize both the functions simultaneously. It is not like that you take one objective function one time and then second objective function second time. No, you have to optimize both the functions at the same time. Now, which type of approaches you can use? That approaches is the goal programming, fuzzy goal programming, fuzzy approach. You can use the particle sum optimization. So different techniques you can use to find the satisfactory solution of multi-objective programming problems. Yes. Yes. Are you satisfied with my answer? Are you satisfied with my answer?
Yes, sir. Yes, sir. There is no doubt.
So any other query, any other questions regarding multi-objective programming problems? From the participant at different nodal centers? From the participant of different nodal centers? No question? Okay. Now we come to the multi-objective linear fractional programming. See, it is again extension of multi-objective programming problems. So multi-objective linear fractional programming problem seeks to optimize more than one objective function, and objective function are in this format, where fx is equal to gx upon hx. Right, both are linear, numerator upon denominator, where g, x and hix are linear function, and here we assume that the denominator of each objective function is non-zero in the feasible set, in feasible region. That is the assumption we need to take before defining the multiple objective linear fractional programming. When we come to the linear fractional, it is necessary to define these assumptions. If denominator becomes 0 in feasible region, you cannot find a solution. This is the mathematical format of multi-objective linear fractional program. You can see multi-objective linear fractional programming problem are to optimize more than one objective function. We want the maximum value of each and every of k objective function in this case, subject to set of constraints, and where Zi is Cix upon Dix, where objective functions are in the form of fractional function. So you can also convert your problem into this format. It becomes more complex. So we have solution techniques which are already in research papers. Goal programming is the easiest, or fuzzy approach is also easiest. You can apply that problems, that approaches to find the satisfactory solution. So automatically then your paper will be published in good journals. And CIDX are the elements of Euclidean space, and for all I is equal to 1 to k, your denominator part dx must be positive. We assume that must be positive for all the elements of your feasible region. X belongs to S. S is the set of feasible region. Feasible set is denoted by this. S belongs to X. X belongs to Ax is equal to less than equals to B. X is greater than 0. And other terms have usual meanings. A is the coefficient matrix, B is requirement matrix, Z is the C upon D. These are the cost matrix, C in numerator, D is a cost matrix in denominator. Yeah, we will take any example. हाँ, अभी बताते हैं. This is the example of multi-objective linear fractional programming problem. Linear fractional. Now you want to maximize this function. 5x1 plus 3x2, and then your 5x1 plus 2x2. First function is there. Second is minus x1 plus 5x2 and divided by x1 plus x2. Subject to constraints. We have taken these constraints. 3x1. This is a numerical example of multi-objective linear fractional programming. You can see we want to maximize two objective functions. Both objective functions are in fractional form. Yes. Linear fractional होता तो केवल एक objective function. Multi-objective linear fractional it means there are more than one objective function, and objective function are in linear fractional form. Right? So this is the numerical example of your multi-objective linear fractional program. Yes, any questions from participant at different nodal centers?
Hello.
Yes.
Sir, this is Ashish Katyal for MIT Meerut, sir.
Yeah.
Sir, in our yesterday class, you had told us that different examples. Right now, you had written the only the equation of that. For example, 5x1 plus 3x2. In our last class, we had studied about the optimization by using certain example. Sir, can you give certain examples so that we can understand non-linear programming better?
See, we will come to the non-linear programming problems, but now we are dealing with the multi-objective programming problems. So this
Yes,
is the
sir.
numerical example of multiple objective linear fractional programming problems. So this is the numerical example where we want to maximize two objective functions, and both objective functions are in linear fractional format.
Sir, sir, last time you had given certain example like how to mix, how to find optimized solution of cement and certain pot and certain examples you had given. Right now you had given about multi-functional, but certain statement is missing, sir. How can we correlate that how 5x1 plus 3x2 come from this?
See, yesterday, day before yesterday, I have delivered linear programming,
Yes, sir. Yes, sir.
and solution techniques.
Yes, sir. Yes, sir.
And then after, one expert was from Punjab University. She
Yes, sir.
delivered
Yesterday.
transportation problem and traveling salesman problem.
Yes, sir.
Then after lunch, I have delivered the MATLAB and an
Yes,
introduction.
sir. You had given certain demonstration how to write matrix in MATLAB.
Yeah. So I can't understand what you are asking about the.
Actually, sir, you had written the statement. We have to find. Sir, problem is missing.
Yeah. You can ask me that what is the you.
Yes, sir.
If you want to say we need to find the value of x1 and x2 which maximize both the objective function and satisfying this set of constraints. That is the
Exactly, sir.
problem.
Yes,
Yes.
sir.
So in mathematical format, we write in this format only. It is understood that we want to find value of x1 and x2. So when you write in mathematical format, it is understood that we want to know the value of x1 and x2 which maximize both the objective function, and that solution will be the satisfactory solution
Sir,
in case of multi-objective.
Sir, can you give certain any example so that we can correlate with the statement that how can we write these kind of numerical example?
No, you want to correlate this numerical example.
So yes, sir. For example, in your first day, you had told us that there are certain workers, there are certain time constraints.
I am giving you the example that, for example, I am the owner of a manufacturing firm,
Yes,
and
sir.
I have two objectives. I want to maximize my profit
Yes, sir.
as well as I want to minimize my cost.
Yes, sir.
So I make a function. A numerator part is my profit and
Okay, sir.
denominator part is my cost.
Okay, sir.
When I want to maximize this, it means I want to maximize my profit numerator part,
Okay, sir.
and if I minimize this denominator, automatically my total function will be maximized.
Maximize. Yes, sir.
So you can take your problem profit upon cost automatically for one objective function. Similarly, for your another product, you can also formulate this profit upon cost.
Okay,
So
sir.
that
The second
problem
comma
becomes,
statement represent the second objective function.
yeah.
Okay.
For
sir.
second
Right now, I
product,
understand.
yeah.
I got the point, sir. Thank you, sir.
Thank you. So this is the numerical example. Any other questions? Any other questions or query? No question? Any other questions, query from participant at different nodal centers? No question? Okay. So now we come to the multi-objective linear plus linear fractional. At the same time, we have multiple objectives, but objective function are in the form of linear plus linear fractional. These all are extension problem basically. Multiple objectives programming problem is a one broad area where different extension problems are there. But the theory of problems, theory related to the problem and solution techniques are different, varies from one to another problem. We cannot apply a same method to multi-objective linear fractional linear problem to multi-objective linear fractional. Both have different techniques. So when multi-objective linear plus linear fractional programming problem seeks to optimize more than one objective function of this format, where this is linear function fx plus gx upon hx. It is linear plus linear fractional. That is the sum of linear and a quotient function where fi, f, g and h are linear function. And also we assume that the denominator of fractional part, this hx, of each objective function is non-zero on the feasible set. It is very important when we talk about the fractional, then we need to assume that denominator is non-zero. When denominator becomes zero, then it is very difficult to find the optimal solution, satisfactory solution. This is mathematical format. The same way, all have usual meanings, only the change in objective function. Lx plus Cix plus Dix. Right? Objective function are considered as in this format. And again, we assume that dix is greater than 0 in the feasible region. You can see we want to maximize or minimize more than one objective function, that is k objective functions, subject to the set of constraints. There are some constraint, ax is equal to less than or maybe greater than equals to b, and x is greater than equals to. So how you will solve these problems, that is important. So different approaches has been given by the researchers. More and more different approaches are given. Traditionally, we have goal programming or weighted algorithm approach, but now soft computing techniques are also being applied to solve these problems. This is the example of multi-objective linear plus fractional, linear plus linear fractional programming problem. You can see earlier we have two objective function in fractional format. Now we have again two objective function in, this is linear plus linear fractional format. You have some problems, you have formulated that problem into this format. Then how you will find the solution which will give the satisfactory solution to each and every objective function. Because in that situation it is very difficult to find the optimal solution in case of multi-objective. So we find the satisfactory solution to the problem. If, for example, I want to maximize my profit as well as I also want to minimize minimize our investment, so it is sometimes it's become impossible. Not so at a satisfactory level, we can find that our profit is also maximized and we have minimum investment. So that type of problem can be formulated as a multi-objective programming problem. But again, your objective function may be in different format, maybe in linear format, maybe in non-linear format, maybe in linear plus linear fractional. So you have different problems. Accordingly, you need to use the different solution approaches according to your problem. So this is the example of multi-objective linear plus linear fractional, in which objective function are in this format, fx plus hx upon gx, and where the objective function is f2x plus 2x1 plus 6x2 upon x1 plus x2. Now you can see this is linear part. This is fractional part where 2x1 plus 6x2 is the numerator and x1 plus x2 plus x1 is denominator part. We have another objective function, that is z2. By error it has been written z1. It is z2, second objective function. It is in different format. And set of constraint. You can see first constraint is of less than sign, second is also less than sign, and third is of equal to sign. Now this becomes a feasible region. We have plotted the graphs also, but theory of LPP will not work on that. Theory of LPP was based on the fundamental theorem of LPP. It said कि उनके extreme corner पे ही आपको जो है it will give the optimal solution. But in case of multi-objective, this theory will not apply. That fundamental theorem was for only linear programming. अब आप केवल corners को check करके you cannot identify that will be the satisfactory solution, because now the region has infinite number of points. Now you have to search the solution which is the best solution, satisfactory solution. So for that purpose you can use the search method also, like we are reading the optimization search method, particle swarm optimization, some different genetical algorithm you can also use. Even you can use the fuzzy approach. Now the picture is clear. You have to find the best solution. For best solution you can use different approaches. आपको एक region दे दिया है, that is the region. Now you find corner पर नहीं होगा. You will not get the satisfactory solution always at the corner of feasible region. Earlier LPP has a important characteristic that the corner will give the maximum solution, but in multi-objective this will not apply. Even linear fractional programming problem, this will not apply. So now you can use the search method, or either you can use the fuzzy goal programming. It is important tools. you can use. Fuzzy approach you can use. Even now people are also using for searching the genetic algorithms where the points are considered as two chromosomes, and then searching is there. Right? So it is all up to you. If you have problem, you can formulate that problem into this format, and then you can apply the solution technique. More and more research papers are there where different approaches are given. Different approaches for particular. If you search on Google that multi-objective programming problem with goal, you will have a book also with goal programming. Multi-objective with particle sum optimization, you will have many research papers. So more and more people are working on that field. But the question is, if you want to publish your paper in good journal, you are from engineering side, you have some practical application also, you have some data. So when that data is formulated into this problem and solution technique is applied, then you will have advantage of getting your work published in very good journals because you have data. From my point of view, I am from mathematics background. I don't have data. I don't have practical exposure, practical application of that problem. I know how to deal with the problem, how to solve them, but I don't have any practical application. That is drawback to me. But for your side, you have data, you have practical problems. You can formulate that problem into this format. Then you can apply. So I think we should have a cup of tea. Then we will meet again, and we will also try to cover the simplex method. Simplex method is important. So on first day we have missed the simplex method due to our time constraints. Right. So we have all the participants. We should have a cup of tea. It is a tea break of 15 minutes. After 15 minutes, we will again meet you. टी ब्रेक कर दीजिए. connected. So I am continuing on multi-objective programming problems. Now we have multi-objective non-linear programming problem. Again, it is extension of multi-objective programming problems, where objective functions, some of the objective functions, or any of the objective function, or any of the constraint is non-linear function. Means there is no linear relationship between the variables. So multi-objective non-linear programming problem seeks to optimize more than one objective function of this format, where fi is non-linear function. All your fi from 1 to k are non-linear function subject to linear constants. Even constraint may also be non-linear. Right? It is not necessary that only the objective function should be non-linear. Your constraint may be non-linear also. Under the assumption that the set of feasible solution is a convex polyhedron with finite number of extreme corners, and if there is a denominator, your denominator must be पॉजिटिव. यहाँ पे भी एक चीज अज्यूम मानते हैं कि जो आपका फिजिबल रीजन है, जो एरिया है, दैट शुड बी फाइनाइट, दैट शुड बी ए बाउंडेड कॉन्वेक्स पॉलीहेड्रल फॉर्मेट, यानी कि इट मस्ट हैव फाइनाइट नंबर ऑफ एक्सट्रीम कॉर्नर्स. राइट, अगर एक्सटेंडेड रीजन होगा, अनबाउंडेड रीजन होगा, देन वी कैनॉट फाइंड द सॉल्यूशन. So it is necessary to assume that your feasible region must be a finite feasible region or bounded feasible region, or we can say it is a convex polyhedron with finite number of extreme points. Finite number of extreme points होंगे तो obviously it will be some closed feasible region. So this is the mathematical format. Again we have k number of objective functions. All objective functions, any of the objective function is non-linear. At least one objective function is non-linear, then we also say it is non-linear, multi-objective non-linear programming. Right? Again, multi-objective non-linear programming problems have two parts. Quadratic programming problem, that is a different part, that is a different characteristics, and this is, you say any of the objective function is non-linear, then we can say it is a multi-objective non-linear programming problem. This is mathematical format. Here more than one objective function is there, k number of objective functions are there, and this is set of constraint, set of feasible set, x belongs to S, ax less than equals to greater than b, and where all, at least one of the ith value of 1 to k, if zi is non-linear, then we say it is a multi-objective non-linear programming problems. So these are extension problem of multi-objective programming problems. Multi-objective means we want to optimize more than one conflicting objective functions. If your objective functions are in linear fractional form, we say it is a multi-objective linear fractional program. Objective functions are non-linear, then we say multi-objective non-linear program. So these are extension problems. But the question is, the theory of one problem is different from the theory of other problem. That is why we need to show that these are the different problems. Then multi-objective quadratic programming problem. Again, multi-objective quadratic programming problems are also non-linear programming problems, because objective function are in quadratic format, quadratic function. Then multi-objective quadratic programming problems are non-linear, having objective function that contain both linear and quadratic forms. Means your objective function are in quadratic form. As we know that quadratic form is just like, for example, the function is like fix is say cix plus x transpose dix. This is your linear part, a linear function. This is your quadratic function. So it is single objective, one objective function which has two parts, one is linear and quadratic. So in case we define multiple objective function max mini of f1 x or f2 x and up to fkx, where I is from 1 to k, subject to x belongs to S, set of S. So this type of problem is called your multi-objective quadratic problem. This has linear as well as quadratic. Quadratic form means like this. Function is like two parts. This is linear and this is quadratic. This is quadratic part. So again, this type of problem is called multi-objective quadratic programming. These are extension problems, obviously. These are not any individual problems. These are extension problems. But for every problem, we need to use the different techniques. Now the objective function is different. You cannot apply the theory of LPP, theory of linear programming. Okay? So it is non-linear programming problem, but its non-linear format has a specific format in quadratic. Linear function is there as well as quadratic. So it is called multi-objective quadratic programming. You can see quadratic function has different characteristics. Quadratic function is convex or concave. Then we are using that property in order to find some satisfactory solution for multi-objective quadratic programming. That is the difference. Okay? So each problem has different characteristics and different properties. That's why we use the different approaches to deal with the different problems. That is the beauty of multi-objective programming. Okay? We are only delivering the introduction of multi-objective and their extension problems. We are not come to the solution techniques. Because for particular problem, we have different techniques. Right? So now we come to the.
So how would this equation multi-objective?
This is not multi-objective. This.
Example.
No, this is single.
Single.
This is single quadratic function. This is normal. But I have given example. This is a quadratic function. This is the mathematical format as I have described in the blackboard also. The same. Mathematically, multi-objective quadratic programming problem can be formulated in this way. Here you can see there are k number of objective functions. Each and every objective function in this format. This is CIX, it is linear part, and this is quadratic part. And even quadratic part can be written as a product of two linear functions. Right? At the same time, you can also write x1 square plus 2x1 x2 plus x2 square as a x1 plus x2 ka whole square, or x1 plus x2 multiplied by x1 plus x2. So that is the quadratic form. So quadratic form in matrix format we will write in this format: x transpose di x. You can write in matrix format also. Clear? You can go on ahead, or we need to. So you can. I can give you a brief idea about this. This is say 1 x1 x2 plus x1 x2, 1, 0, 0, 1. You can convert into matrix form. So this is your x1 plus x2, x1 plus x2, and this is your quadratic part. x1 plus x2 we can write in matrix form 1 1 multiplied by column matrix. So when we product them, x1 plus x2 will be there. इस फॉर्मेट को, दिस इज क्वाड्रेटिक फॉर्मेट, इसको हमने मैट्रिक्स फॉर्मेट में लिखा है x1 x2 एंड दिस इज यूनिट मैट्रिक्स. इसका एक प्रोसेस है कैसे यूनिट मैट्रिक्स को डिफाइन करते हैं, एंड दिस इज योर कॉलम. व्हेन वी मल्टीप्लाई देम इट विल बी x1 एंड देन x2. जब दोनों को आप मल्टीप्लाई करेंगे देन इट विल बी लाइक we should write x1 half of 1 and 1. Then maybe it is basically x1 square plus x2 square. So if we take x1 x2, then we multiply them, we will have the same. So your matrix will be 1 1 1 1. Okay? तो जब इसको मल्टीप्लाई करेंगे, इसको मैं वापस लिख रहा हूँ x1 plus x2, then again x1 plus x2, then multiplied by x1 x2. इसको मल्टीप्लाई करेंगे x1 square plus x1 x2 plus x1 x2, then x2 square. Okay. So you can see this is your C part, this is your capital X decision variable, this is your X, and this is your D part and X transpose. This is your X transpose, because we are defining X as a column matrix. So if this is X, this will be your X transpose. This is your D matrix, and this is your X. Okay. So when we multiply them in matrix form, your quadratic function can be written as X transpose dx. Okay. Okay. So this is the case where objective function is in quadratic form. And other notation have usual meanings. They have usual meanings. This is the format, one of the numerical example of multi-objective. We have taken one example of simple quadratic form, and now in case of multi-objective, so this is numerical example. You can see there are two objective functions, Z1, Z2, and Z1 is in quadratic form. You can see this is the quadratic form and this is linear form. This. And Z2 is also in quadratic form. This is quadratic format and this is linear and subject to the constants, set of constants. Now how you will find the solution which is satisfactory to both of the quadratic functions? That is the question. The problem of determining x1, x2 which give the satisfactory solution to both the objective functions satisfying all the constraints, that will be the satisfactory solution. That type of problem is known as the multi-objective quadratic programming. Right? Clear? I think.
So how you can decide, sir, the particular solution is best? How do you decide?
See, that is all up to you. That see, you have defined the feasible region. You have two objective functions. Now feasible region has infinite number of points. आपने ग्राफ बनाया, उसमें तो कॉर्नर चेक कर ली, but here the theory of LPP will not work. Now it is all up to you how you will locate that best solution, which optimize, which give the satisfactory value of every objective function.
So it depends on perception of a person.
No, it depends upon the criteria taken by the person. For example, a fuzzy approach, we are using the membership function. We convert the objective function in membership form and we try to find the maximum value of membership function, close to 1. And different approaches will have different criteria, because you cannot decide without criteria, we cannot decide what will be the solution. Your satisfactory level you must define before using the technique. Otherwise, the solution which give the maximum value of Z1 and Z2 both, I think it is not rarely happens, but it is difficult to find. So satisfactory solution we can obtain, and obtaining that solution we have different approaches. For example, for person I am using fuzzy approach, you person you are using a search method in order to find some of good solutions. The person who is working on another field, they are using the neural network techniques. They define the feasible region, your variables in terms of some neural networks. Then they find some solutions. So there are different solution techniques. But it's rarely happened that we find the optimal solution of that complex problem. Even for two objective function, it is quite difficult. For example, if you have 100 objective function, I don't think we can find the optimal solution. So we use the satisfactory solution, or sometimes we use the compromise optimal solution. We also use the Pareto optimal solution. These are some detailed definition related to the multi-objective programming problem. But in this session, we will only describe you what is the multi-objective programming problem and what are their extension problems. Because the person who is working in this field, and then only I can discuss about the Pareto optimal solution and further. So in this lecture, we are only restrict ourselves to define you the extension problems. So it is based on criteria. You are absolutely correct. Without criteria, you cannot. So you have decided that if 50% goal is achieved, the technique is good for multi-objective quadratic. PSO is good, for example. At the same time, fuzzy logic is not. It's good for the multi-objective linear programming. So it's very problem to problem is dependent. You cannot say that only this method is very good for multi-objective quadratic. You cannot say. Even the value of numerical values are also affecting the solutions. Right? Now we come to more complex multi-objective quadratic fractional. This is the case of multi-objective quadratic fractional programming, where quadratic part is also there as well as fractional part is also there. You can see this is the problem, and we have k number of objective functions, and each and every objective function are in fractional format, where numerator is also a quadratic function and denominator is also a quadratic function. This quadratic function can be written as the product of two linear functions. For example, in this case, x1 square plus 2x1 x2 plus x2 square can be written as x1 plus x2 multiplied by x1 plus x2. So here this is linear function multiplied by another linear function with different coefficients, lambda I, ci, only coefficient will change. So this is the quadratic form. We can also write numerator part as x transpose some dix, and denominator we also can write the x transpose eix, d इसमें आ गया और e इसमें आ गया. So this becomes the quadratic fractional. It is also have the properties quadratic as well as fractional. So it becomes more complex because now you cannot. It is feasible region is there, but properties of linear program will help you. Even quadratic fractional properties will not help because it is quadratic as well as fractional also. So different techniques, like you can reducing techniques was traditional methods. Now fuzzy approach is being used in order to deal with this type of problems. So many research papers are available. If you search on multi-objective and solution techniques, now I think book is also published related to the multi-objective programming problems. But it is all up to you how your problem can be formulated in these problems. If you give me the data, I can formulate. That is. But I don't have data. I don't have any practical situation problem where I can use. But you have this advantage. Even you can formulate your any problem in multi-objective if you have that data. So this is the extension problem of multi-objective programming problem. This is the numerical example. Again, you can see this is the case of multi-objective. Two objective functions are there. Again, both functions are in quadratic form, numerator upon denominator. And set of constraint is this. This is the region. Now what will be the satisfactory solution? Now it becomes more complex. Clear? Yes, any question, any query from the participant at different nodal centers? Any question?
Hello.
Ah, yes.
Sir, this is MI numerical.
Yes,
Sir,
yes.
here in numerical example, there is no quadratic equation that is mentioned. Only linear equation is mentioned. No square, no cube is mentioned here in X, Z1 or Z2.
Z1.
The
See,
example which.
see, if you multiply them, you will have quadratic fractional part.
Okay, sir. Okay. Thank you, sir.
But it is not necessary that each and every variable should be there.
Okay, sir.
I know that if you multiply them, you will have quadratic fractional in x3 and x4.
Yes, sir.
Not in x1, x2. I understand. But quadratic function is also there. If you multiply them, you will have 2x3 square plus 20x4x3 plus 12x3.
Okay,
and then you will have linear part as well as quadratic function.
Okay, thank you, sir.
Okay. Any other question? Any other query? Any other question? Query? Please connect to Jaipur MIT. Yes, any question? Any query?
No, sir. Thank you, sir. Thank you.
Okay. From on multi-object. See, Now people are producing the books on Indian authors. But if you Google, you have so many books, e-books are available on multi-objective. But the question, the limitation of that books is that, for example, I am from mathematics background. So my area of research is different from that of you. So which book is suitable to me, that I will decide. So multi-objective is a broad area, and if you search on Google, you will have so many number of e-books also. So it is better ki first you learn the basic of multi-objective. Right? Now the person who is from IIT Kharagpur has published one book on multi-objective from CRC Press publication. Earlier I was willing to publish that book, but already the people has published, so I dropped the idea. So many books are available. Many good books are available by Springer, by elsewhere. They have good books. But for particular your problem, it is better to take the research papers, because when we read the books, there are so many useless things we have to read it out. So if you are working on particular point, well, so it is better to take the research paper on particular problem, where the multi-objective programming is used. It is the simplest way. जब आप बुक पढ़ते हैं तो बुक में तो एक चैप्टर वाइज होती है जो आपके यूजफुल हो, मैथमेटिकल्स भी हो सकते हैं, हो सकता है कुछ और. बेसिकली दे आर अ कलेक्शन ऑफ रिसर्च पेपर. एट प्रेजेंटली बुक्स इन मल्टी ऑब्जेक्टिव आर जस्ट अ कलेक्शन ऑफ रिसर्च. एक सिस्टमैटिक बुक इज नॉट देयर. So obviously you have to read the different useless papers also. That is the drawback of what I think, in my point of view, is the book, reading the book. So it is better to take the research paper, article 2, 3, which are relevant to your topic, and then analysis the multi-object. Now we have one example. Say it is our feasible region, and we have taken the feasible region, some feasible region I have taken. So suppose a person named Woody wants to simultaneously optimize two objective functions. These two objective functions, one is of maximum and second is minimum. Right? So you can see both are conflicting. They are not in one direction because coefficients are different. They are not in proportional form, or even they are not similar type. So you can convert this minimization problem into maximization, because these are the linear problems. A linear LPP can be converted, objective function can be converted into minimization to maximization by just multiplying with -1. Over the feasible, some region I have skipped this region and say for 3 variables. Now I assume that the optimal solution for objective function first is 1500. I assume that the best solution, the best answer for individual objective function Z1 is 1500, and with optimal objective value is 750. Right? But unfortunately, it is also that the worst possible value for Z2 is 600 at this point. However, it is a best solution for Z1, but it is just worst solution for the Z2. It is only 600 for value of Z2 for this solution. So using objective Z2, on other hand, we get the best solution at 0, 0. If we take individually Z2 is this -40 x1 -20 x2 -10. What will be the best solution? 0, 0, because I want to maximize this. If you are taking the objective function separately, we are talking about the separate optimal solution. So for first objective function, your optimal solution is 1500, and for individual second objective function, your solution is 0, 0. Now what will be the solution? Because if you are taking 1500, it will be the worst solution for the second objective function. If you are taking 00, it will be best solution for second objective function, but the worst solution for the first objective function. Isn't it? Right? So this is of maximization, this is of minimization. We have converted minimization into maximization problem. अब इसको maximize करना है तो क्या solution लेंगे? 0, 0. Because we want to maximize negative quantity. So it is better to take 0, 0. But 0, 0 will give the minimum value of first function. And 1500 is the best solution for first function, but worst solution for the second function. So using Z2, on the other hand, we get the solution 0, 0 with optimal objective value 0, which is likewise the worst possible value for the objective function Z2. So both the functions are conflicting in nature. And now to find the satisfactory solution of this problem is called the multi-objective programming problem. See, we have two objective functions. One is of maximization. It is 50x1 plus 70x2 plus 80x3. And second is Z2. It is of minimization. I want to find a solution which optimizes both the objective functions simultaneously. So for minimization problem, I convert it into maximization problem by multiplying it -1. Because if you want to minimize a linear function, it means you want to maximize the linear function multiplied by -1. Right? So this becomes two objective function. This is maximization, this is also maximization. Over some feasible region. Feasible region is there. Now I assume that the x1, x2, x3 is equal to 1500 is the best solution, optimum solution for Z1 individually, not simultaneously. Individually we are taking, it is best solution for Z1, and correspondingly value of Z1 is 750 for at this point. But unfortunately this is the worst solution for Z2. If you put 1500 into second, it will be your -600 maximum value. And if you take minimum Z, it will be 600. It will be worst solution to the second objective function. If you take individually, जैसे आपने कहा था, why don't we take the individual solutions? But the question is, you have to find the solution simultaneously. Right? आप ये देख लीजिए, एक मैन्युफैक्चरिंग फर्म में, I want to maximize my profit as well as I want to minimize my cost also. Now what will be the best solution which will maximize my profit as well as minimize my cost? ऐसा नहीं individually we cannot कि individually profit maximize करना है और individually cost जो है वो minimize करें. No, simultaneously we find the solution. We want the solution which simultaneously optimize the objective functions. That type of problem is multi-objective programming. तो आप सेपरेटली अगर Z2 का सॉल्यूशन फाइंड आउट करें, आपका ऑप्टिमम, इट विल बी 0, 0 एंड it has minimum value 0, but again this solution is the worst solution for Z1. Now how do we resolve these objectives, conflicting objectives? This is the case of multi-objective programming problems. For any person who has some problem, this problem is of maximization. One objective function is maximization, second is of minimization. This is a simple case of multi-objective programming problem with two objective functions.
Sir, we consider x2 will be 0 and x3 will be 0, so there is no participation of the variable.
We consider x1,
x2 is equal to 0
and
x3 is equal to 0 in first situation, 15, 0, 0. So there is no participation of the decision variable. So what is the use of
Sir, we have taken example and we are not mentioning the feasible region. There are some conditions. So according to condition, I have assumed that this is the solution for first objective function. So it's okay कि x2 और x3 का contribution नहीं मान रहे हैं. हो सकता है according to feasible set of constraint, maybe some solution may be there. But for example point of view, we are taking to understand what is the problem. So अगर individually एक के लिए जो optimal solution है, that may be or may not be your optimal solution to the second objective. Right? So this is the case of multi-objective programming problem. जो चीज मेरे लिए मैक्सिमाइजेशन हो सकता है वो दूसरे प्रोडक्ट के लिए मिनिमाइजेशन के लिए वर्क करे. Right? So we cannot optimize each and every objective function simultaneously. Rarely it happens. It happens rarely, but we can find out the satisfactory solution. It is better. So we have taken one example. What is the basic multi-objective programming problem? This is the case of multi-objective programming. Yes. Any question? Any query? No question? Any question? So we have taken one example. It is not clear कि feasible region क्या है, हमने उसको जो hide किया, right? So earlier we were have traditional methods. So I want to have some discussion on solution techniques also. So earlier we were using a weighted aggregated problem method where we combine the objective function according to their weight. Okay, for example, for first objective function I give the weight 1. For second objective function I give weight 50% according to our criteria की which is most जो है suitable है या most desired है. Accordingly we give the weights also. So this is our traditional method. It is linear aggregated weighted multi-objective method. You can see अब एक क्वेश्चन ये भी आता है सारे ऑब्जेक्टिव्स हैं उनको जोड़ दो, then it becomes a linear programming or single objective. But we cannot combine. Profit मेरे लिए कितना important है, cost कितना, I don't know. We cannot club them simultaneously. Right? So this is traditional method and this is not up to the mark method, and weighted method is now very old and I think इसका ज़्यादा use भी नहीं होता है because the solution is not up to the mark. But in this session we try to have some discussion on this method as an initial method. So in this method we convert the multi-objective programming problem into simple single objective problem by summation of weighted objectives. Like there are k functions, say there are I number of functions. So we have combined them. We have make a combination of these functions with weights. W1 is the weight of Z1 and weights are their relative importance. How much importance is given to first objective, how much importance is given to the second objective, these are considered as a weight. आपके लिए प्रॉफिट कितना इंपॉर्टेंस है, कॉस्ट कितनी इंपॉर्टेंस है, इन्वेस्टमेंट कितना इंपॉर्टेंस है, all will be given a different weights. Then we combine them and now this problem is converted into single objective programming problem. Then we can use our graphical method or simplex method or non-linear. If constants are non-linear, then non-linear methods we can use, and then we can find the satisfactory solution with reference of your relative importance. So this is converted into a single objective programming problem subject to the constants, and where W1, W2, Wi is the relative importance of objective functions. For example, for first objective function it is not important to me, I give 10% weightage. Second objective function cost is very important to me, I give 80%. Investment is not important, I give 10%. So W1 हो जाएगा 0.10, W2 will be 0.80 and W3 will be 0.10. So weights can be decided according to your requirement. Relative importance, what are the importance of objective function. This is traditional method, but this method has certain limitations, some certain drawbacks are there, because sometimes the weights are according to our requirement. Sometimes when weights are equal, you cannot club them as a single objective.
Excuse me, sir.
Yes.
Sir, sir, there is a question. Sir, weightage means we are assigning probability to individual task. For
No.
example, you had told us that 10% means we are assigning 10% probability. Means out of 100, we are assuming that 10% is in Z1, 80% in Z2, and remaining is 0.
See, we cannot use the term probability. First thing is that importance are given in terms of weights that are numerical values. For example, your profit is your important, but it is only of 50% importance. There you have three objectives. First objective, in your point of view, it is 40% important to me. Second objective, it is 30% importance to you, and your third objective is also 30%. So weights will be 0.40 for the first objective function, 0.30 for second objective function, and 0.30 for third objective function. We cannot use the term probability because probability is not appropriate terms. Weights means their relative importance is given in terms of numerical values.
Okay, sir. Sir, where in case of ANN, we also use weightage to define whether the given node is working or not. We are also using weight in that terms also.
Where?
In case of neural networks, sir,
Yeah.
we also use weightage.
Yes.
Under that, we use probability terms.
See, that is a different type of problem where you use the probability distributions,
Yes,
right?
sir.
So, but this is a very simple problem where we are just combining the objective function with their weights.
Okay, sir.
We are not dealing with the neural networks where we probability distribution and so long calculation there. This is simple problem. We have converted this multi-objective programming problem into single objective.
Okay, thank you, sir.
So you can see this is only one objective function we will have.
Yes, sir.
This is single objective. Any other question? Any other questions, query from other participant of different nodal centers?
हेलो सर.
हाँ, yes.
आपका आवाज सुनाई दे रही है सर?
हाँ, सुनाई दे रही है.
मैं सर ये कह रहा था कि हम जैसे ये जो वाटर के एनालिसिस करते हैं,
हाँ.
उसमें डिफरेंट पैरामीटर्स है.
Yes.
ना होगा जैसे फ्लोराइड है,
हाँ.
टोटल हार्डनेस है,
हाँ.
टोटल डिजोल्व सॉलिड्स है. तो ये काफी सारी चीजें हैं, करीब 200 पैरामीटर्स है.
Good.
तो अब इसमें जिसकी ज्यादा इम्पोर्टेंस है,
हाँ.
तो हम 10 पैरामीटर ले रहे हैं.
हाँ.
10 पैरामीटर्स में अब कोई प्रॉब्लम चल रही है, जैसे सपोज करो कि अभी कोई हार्ट की प्रॉब्लम चल रही है किसी एरिया में, ठीक है सर. और उसमें पानी का सैंपल लेते हैं, हमारे पास सैंपल का रिकॉर्डिंग है, और हमारे पास में रिमोट सेंसिंग के उनके लास्ट 5 इयर्स के डेटा भी है, और उससे जो कनेक्टेड पैरामीटर है उसको हम कितना वेट देंगे, और जो बाकी वाले जो पैरामीटर्स हैं उनको कितना वेट दें.
See, it is all up to you.
हार्ट से रिलेटेड बात करें, और हार्ट से रिलेटेड मान लो 2 पैरामीटर ज्यादा इम्पोर्टेंट. अब उसमें कहे कि साहब आपके जो डिजोल्व सॉलिड्स है उसकी वजह से हार्ट में प्रॉब्लम आ रही है, कार्डियोवैस्कुलर डिजीज फैली हुई है ज्यादा, जैसे हम किसी जयपुर के एरिया की बात करें, और उसमें लास्ट 5 इयर्स के हम डेटा यहाँ कलेक्ट करते हैं, तो उसका कैसे ऑप्टिमाइजेशन करें.
See, आपके पास डेटा है, राइट? अब आपको ये डिसाइड करना है कि किस पैरामीटर को कितना वेट देना है.
मैंने कहा ना सर, जैसे हमने टीडीएस को ज्यादा वेट दे दिया, उसको भी मानते हैं कि 80% हार्ट की डिजीज का कारण ही टीडीएस है,
ठीक है.
और जो दूसरे पैरामीटर है वो हमारे पास 30 पैरामीटर कहेगी साहब आप इसका पानी का टेस्ट देख लो, तो पानी तो पीने में अच्छा लग रहा है. तो इस तरह के पैरामीटर्स है, तो यहाँ जो W1, W2, W3 जो लास्ट है वो कैसे.
See, आपने एक पैरामीटर डिसाइड कर लिया कि जो TDS है दैट इज गिवन 80% इम्पोर्टेंस.
जी जी,
ठीक है. तो इसको आप एज ए वेट्स में लेंगे 0.80
पर्टिकुलर फंक्शन के लिए.
यस, पर्टिकुलर के लिए. देन रेस्ट ऑफ द पैरामीटर्स को आप कैसे जज करते हैं, कितना इम्पोर्टेंस है और उनको आप कितना इम्पोर्टेंस देते हैं. जैसे दूसरे पैरामीटर हैं आपके फ्लोराइड है, और कुछ मेटेरियल है, then according you as an expert you will decide how much weightage can be given to that parameter. It is all up to you. You will decide which objective function will be given how much importance. It is dependent upon your problem to problem. We cannot have a fixed criteria to decide this will be your weight.
इससे सॉल्यूशन निकल सकता है क्या किसी का?
हाँ, इससे निकल सकता है, बिल्कुल सॉल्यूशन आएगा. और
पैरामीटर्स भी दिखा रहे हैं, फिर जगह जगह भी सैंपल देते हैं उनके, फिर 5 साल के, फिर महीने के, जैसे किसी कुएं के लिए तो बैठता करीब 2, मतलब काफी कॉम्प्लिकेटेड, थाउजेंड्स में वो पैरामीटर्स.
अगर आपने उसका मल्टी ऑब्जेक्टिव प्रोग्रामिंग प्रॉब्लम को इसमें कन्वर्ट कर लिया तो चाहे 100 पैरामीटर हो, चाहे आपके 1000 पैरामीटर हो, और उनको आपने कन्वर्ट कर लिया तो सॉल्यूशन की टेक्निक्स अवेलेबल है. इवन इन सिंपल सॉफ्टवेयर, लिंगो सॉफ्टवेयर, you can deal with the 2000 parameters and 2000 objective functions. Only you need to input the data. There is no problem that how we will solve that. If you have data, we have available tools. आप कहोगे मेरे पास जो है 1,00,000 ऑब्जेक्टिव फंक्शंस हैं, 1,00,000 पैरामीटर्स हैं, even we can solve within a minute. The satisfactory solution will be there within minutes. So we have Lingo software is there, which will deal for the linear programming and multi-objective. You can find.
ये सर फ्री है या कुछ? ये वाला सॉफ्टवेयर फ्री है?
हाँ, ये वाला आप ट्रायल वर्जन जो है वो गूगल से ले सकते हैं. फ्री नहीं है ये, लेकिन यू कैन यूज ट्रायल वर्जन. बट ट्रायल वर्जन में आपका जो है 1000 ऑब्जेक्टिव फंक्शंस तक वो वर्क करेगा, 1000 पैरामीटर.
Sir, can you repeat the software name?
Lingo, LINGO. Yes.
Okay, thank you, sir.
You can search on the Google. You can download this software. It is very easy software. You have to just input the data. You will get the solution. Yes. Any other question? So in our case, in this example, as we have taken one example of maximum, one function is of maximum, second is minimum, and we have taken one linear aggregated weighted multi-objective. So we have converted this multi-objective programming problem into single objective. So in our example, just we have there, I give weight 1 to first objective function and 1/2 to my second objective function. Accordingly, I decide that first objective function is more important to me, so I give 1 or 100% to the weight to the first objective function and 1/2 weight to the second objective function. Second objective function is not so important to me, so I give 1/2. So you can see it is 1/2 to objective minus 2. Then resulting weighted objective will be this. It is first objective function minus half second objective function. So it will be converted into single objective function, this 30x1 plus 60x2 plus 75x3. Now you can solve with linear programming problem or non-linear programming problems. Then you can find the solution. And you can see, so using these techniques, we have solution. This is your tan 30. It is satisfactory solution to your problem, and this at this point the maximum weighted sum is over your feasible region is there. And this is the optimal solution for weighted objective functions, not individual, but this is the satisfactory solution for the multi-objective programming. Because you have combined the two objective function into one by giving their weights. So we cannot say this is optimal solution, but this is somehow some satisfactory solution within the feasible region. So in this, we have taken weight 1 to first objective function, 1/2 to second objective function in this. Clear? So now we come to the application of multi-objective. They have wide applications. Even many complex problems are formulated in multi-objectives, because nowadays we have different problems, and different problems we have different objective functions. In our daily life, I also want a good job, good salary, good working environment, and good facility. All are my objectives, but I cannot find the optimal solution to each and every objective. I can find some of the satisfactory solution to my problem. So this is real-time example. For example, in your case, or you want to have good job, same time, maybe some of the criteria be satisfied, or some of will not be satisfied. But this is the application of multi-objective programming problem. So decision-making problems occur in real world are generally multi-objective decision-making problems, because nowadays we don't have one objective, right? We have multiple objectives, and I want to find the optimal solution of each and every objective, but practically it is not possible. So this type of problem can be considered as a multi-objective program problems. So objectives involved in multi-objective decision-making problems are often conflicting, non-commensurable, and fuzzy in nature. Sometimes the raw data is there; they are in fuzzy in nature also. So multi-objective programming techniques give an easy and efficient approach towards the solution of more complex arising in management. So main use of this type of problem is management, because when a management person who is dealing with so many workers, so many parameters, they have this type of problems. So management, defense, what type of strategy we should use in defense, government, so etc. So that the significance of techniques may be useful for the economic growth as well as national development. So if we use this type of techniques, definitely it will give some satisfactory solutions, right? So we have some examples of multi-objective programming problem. One is the production planning problem. This is related to manufacturing industry or some production industry. We have different objective. We want to maximize total net revenue. For a person who is dealing with the production industry at top level management, he wants to maximize his total net revenue. Revenue is important. Second objective is minimize. It is not correct. I think it should be minimum. It is error. It should be in minimum net investment in any period, right? So maximize the minimum net investment. Then minimum of back orders. A manufacturing firm should not have back orders. Orders must be completed within the given time. Minimum overtime. Minimum finished goods in inventory. They don't have stocks. The minimum that stock inventory should be minimum. So these are some of the objective functions. 2 are maximum types and 3 are of minimum type. This is the example of person in production planning problem, which can be formulated as a multi-objective programming problem. And similarly for capital budgeting problem, maximize the net present value. The person who is dealing with the budget and financial sector, they want to how they budget the capital. So maximum net present value, maximum capital investment, more and more investment should be there. Minimum annual operating expenses should be minimum, and maximum investment in project in a given geographical areas. There are different objective functions, and your maximum investment project related to environmental production, and maximum investment in project pertaining to a given product line. So this may be different objectives, and this can be formulated in mathematical format. Then we can find the satisfactory solution. So you have some problem, जैसे अभी discuss किया था, they have data related to some water parameters. So they said कि fluoride or TDS is more important. So this type of problem can be easily converted into a multi-objective programming problem in minimization format, because they want to minimize the parameters. Then they can find a satisfactory solution. What is the exact solution for this problem? Transportation problem. As we know, we want to minimize the cost. A transportation company will feel that we want to minimize the cost, minimize the average shipping time to priority customer. For example, in railway, they use these techniques. Transportation is very important. However, transportation scheduling is different, and when we define the transportation as a multi-objective is different. Transportation problem में मैडम ने जैसे डिस्कस किया था, how you will find the optimum transportation schedule so that the supply and demand must be satisfied. That was, but the same transportation problem can also be formulated as a multi-objective. So we have different objectives. We want to minimize the cost, as well as we want to minimize the average time, average shipping time, maximize the production using the given process, and minimum fuel consumption. We also want to use the technique which give the minimum fuel consumption. So we have 3 objective function in minimum form and 1 objective function in maximum form. So this type of problem can be multi-objective program. This type of problem, of current problem can be solved using multi-objective programming techniques. So there are so many techniques are available. Any question? So these are some of the examples related to industries and financial sectors, management sectors. In your institution may be different objectives. You want the good results from students. You want to have promotions in your organization also. You want good facilities. You want the good fund from government organization. So they have different objective functions. So this type of problem can be considered as a multi-objective programming problems. So any question, any query from your side, if you ask me. It is the easiest, but it is right now it is not relevant because we are using weights generally only. So now what is your question?
My question is that it is one of the method of solving the.
Yes. It is one of the traditional method of solving multi. No, it is used in the person who is not familiar with the other. The person who is, I have read a paper who was from sustainability development in agriculture field. So that paper was published in elsewhere. So in that case, the some agriculture data was there, and that problem was converted into multi-objective, and they used this aggregated method, and paper was published. But in my opinion, that method is not appropriate for, because we are we are trying to convert multi-objective into single. आपने सबको जोड़ा ही है, weighted देखिए. So there are new techniques are available. Will give the better results in comparison of your weighted. So that paper was published, and that paper was published in some agriculture related field, and paper was in elsewhere. So, but if I will publish my paper with aggregated, it will be straightforwardly rejected, because they know I will send paper to some engineering field or mathematics. They will straightforwardly reject it. What is this? This is it is not being used in engineering or science area. But I have seen one paper with this. So it depends upon your area. Right? So any other question? Any other query from your side?
There is one term in programming, heuristic programming.
Huh?
Heuristic programming.
Pardon?
Heuristic programming. Actually.
देखिए, that is heuristic programming is a different.
But I just want to understand what is the meaning.
It is related to the uncertainty programming problems. When your coefficients are have some probability distributions. For example, यहाँ पे आपने C लिखा, X लिखा, A लिखा. These are deterministic. But in case your C or A or B have some probabilistic in nature or probability distribution, then that type of problem is said to be uncertain or heuristic programming problems. So see, mathematical programming problem is a very broad area. Right? Multi-objective is different, heuristic is different, uncertain programming problem is different. Even for uncertain, they have multi-objective uncertain programming problem, multi-objective uncertain linear fractional, all they have different extensions. Right? So it is a big umbrella where different type of programming problems are there. We cannot say it is only LPP or only fractional. Uncertain, heuristic, even hierarchical programming problems are also there. Multi-level, bi-level, multi-objectives. So there are use of programming problems. So we have one table to understand what is the LPP and multi-objective. You can see this is linear programming. We have clubbed this in linear tabular form. Linear. Only one objective function is there. All constants and objective function are in linear format. Right? So it is linear fractional, change in objective function. It is C transpose X divided by D transpose X. It is linear fractional objective programming problem. Only change in objective function is there, because if we change the in constant, it is you can simplify them and it can be converted into linear format. Right? So we have mentioned only in objective function, which is in linear fractional part. It is numerator and denominator, and we assume that denominator is non-zero in the visible region, so that we can find at least finite values. Then this is multi-objective linear. There are more than one objective functions, and all objective functions are in linear format. Then multi-objective linear fractional. This is multi-objective linear fractional programming problem. Again, we have more than one objective functions subject to set of constants, and each objective function in this format. Each and every objective function is in fractional objective functions. Linear numerator divided by denominator. For different problem, we need to use the different theory. That is the main part. You cannot use the same theory LPP in all. No, it will not work, because characteristics of the change, theorems has been changed, each and everything is there. But if you can reduce this problem into LPP, it's all depend upon you. If you can reduce somewhere some substitution, you convert into LPP, then only you can use LPP theory. Then multi-objective linear plus linear fractional. Again, it is extension of this. We have multiple objectives. Now see, the objective functions are linear plus linear fractional. Linear part is added into this. Linear function plus fractional part. Right? This is multi-objective linear fractional, linear plus linear fractional. This is same. And this is multi-objective non-linear programming problem. So each and every objective function in non-linear function. Non-linear function, it is not linear. It means relationship between the variables is non-linear in nature. Right? Linear means each and every variable has power 1. Non-linear means greater than power 2. So this is the multi-objective nonlinear. This is multi-objective quadratic, where each and every objective function in quadratic form. So these all are extension problem of multi-objective. Let you know what is the objective, what is the multi-objective programming problems, right? What are their mathematical format, what are the extension problems, what are their applications, and some of the examples. That is the, we can say, overview about the multi-objective. We have not considered any techniques, because techniques is according to your problem. Then it is up to this. If you have any question, any query, you can ask.
Sir, in weighted method, the summation of the coefficient is weight
Hmm?
must be 1.
See, weight obviously would be 1. For example, weight is relatively importance.
See, in our case, we have considered 1 weight for the
First,
Z1 and half weight for the second. Why so?
because see, it should be in your question is to 1/2 or 1/2 total weight 1
Yeah.
that is your question. बट एज ए एग्जाम्पल हमने उसको 1 लिया है और हाफ लिया है, क्योंकि मैं चाहता हूं कि जो फर्स्ट ऑब्जेक्टिव फंक्शन है उसको मैं 100% इंपॉर्टेंस दूं, सेकंड ऑब्जेक्टिव फंक्शन को 50% इंपॉर्टेंस. तो जरूरी नहीं है कि मेरा जो क्राइटेरिया है वो 1/2 है. आपने ले लिया, मान लीजिए यू वांट टू गिव द 100%, या मान लो आप चाहते हो कि मेरा फर्स्ट ज्यादा इंपॉर्टेंस हो, तो आपने 1 दे दिया, 1/2 दे दिया.
So summation तो 1 नहीं हुआ.
Summation 1 नहीं हुआ. See, these are weights are relative importance.
So
Yes.
it is not rigid criteria.
Yeah, no, it is not rigid. You can also define in decimal also. For example, we are using 1/2. You can use 1, 0.5. You can also use in percentage. It is relative importance. It is all up to you what weight you are giving. It means आप चाहते हैं Z1 is very very important to me. I give weight 100. It is all up to me, but because I want the maximum value of first objective function. So it is all up to the decision maker who is dealing with the problem. Huh?
It is relatively given to the objective function.
Yes,
So usually we are allotting
weights. For example, in your point of view, first objective is important, I give 100 weights. Second is not so important, I give 10. Third is very important, I give 60. These are relatively. Obviously, we are just multiplying. तो जब ऑब्जेक्टिव फंक्शन की वैल्यू निकालोगे तो वो तो सेम ही आएगी, वेट को तो आप इंक्लूड नहीं करोगे ना. सी
the question is what, sir? Suppose there are 3 objective functions. First is to minimize the cost. Second is to maximize the profit. Third one is to minimize the real labor. So we are having different weightage for this.
Okay.
For the first objective function, the weightage is 0.5.
Yes.
For second is 0.4. For third is 0.1.
Yes.
So my question is what? If we sum these fractions.
See, for example, in this case, I give the weight to 200% to first objective and 50% to second objective and 40% to third. So what it indicates, we are giving importance. But जब आप उसको solve करेंगे, Z तो वही रहेगा. It is only to convert multi-objective into single objective. उसका solution आएगा. You have मान लीजिए you have weighted and you find the solution. X1 is equal to 1, 1, and what will be the value of Z? Z will be only Z. It will not be multiplied by weight. So whatever you are giving the weights, it's all up to the decision maker. Z तो वही रहेगा. Z पे तो आपका अफेक्ट नहीं, केवल आपने उसको कन्वर्ट करने के लिए वेट्स का यूज किया. Isn't it? Got my point? क्या आप दे रहे हैं? तो जरूरी नहीं है कि वेट्स जो हैं वो आपके डेसिम मतलब 1 के फॉर्म में हो. वेट्स में भी योर नहीं, no, it is not required. It is all weight relative importance, how much importance you are giving. It is not restriction that the sum of total weights is 1. जब sum of total weights 1 होगा तो 200% को आपको उसको एडजस्ट करना पड़ेगा. ठीक है. So any other questions from the participant at different nodal centers? I ask questions. Yes, any question from the participant at different nodal centers?
Yeah, is there any question from
Any questions, any query?
any center? There's no any question from
Okay. So I think now I conclude this session. Yes. Any question? Any question or query from Jaipur?
No, sir. No, sir. Thank you, sir.
Okay. Mahatma Gandhi University.
So this is Gyan Vihar University, sir. Gyan Vihar University, Jaipur.
Okay, you are from Gyan Vihar University. Okay.
Yes, sir. Yes.
So how many participants are there?
Sir, it's 10 only.
Okay, but how many registered participants are there?
It was 30, sir. Actually, sir, electricity has gone अभी इस समय लाइट गई हुई है हमारे यहाँ और ये अभी बंद होने वाला है हमारा लैपटॉप भी बंद होने वाला है.
अच्छा. Okay. Mahatma Gandhi University.
Sir, Suez Gyan Vihar University, sir. Suez Gyan Vihar University.
No, I want to connect with the Mahatma Gandhi University. That is why I was saying. Nahi. Okay, thank you very much for listening. I conclude my session here. And one simplex method is remaining. So I hope whenever I will have time, I will talk to expert.
Hello, sir. Hello, sir. You are not audible.
Yes, please.
सर दोपहर वाले सेशन में क्या कवर होगा?
दोपहर वाले सेशन में MATLAB प्रोग्रामिंग
जी
for optimization.
Okay, sir. Toolbox.
No, toolbox on tomorrow. Introduction to optimization toolbox and solving linear problem using MATLAB. ये कल होंगे. आज इंट्रोडक्शन, आज MATLAB प्रोग्रामिंग फॉर ऑप्टिमाइजेशन होगा आफ्टरनून में.
ओके ओके सर.
Yeah?
सर आप लेंगे सेशन?
नहीं, डॉक्टर SS धामी लेंगे.
ओके ओके सर. थैंक यू सर.
Thank you very much for listening me.
Thank you, sir. Thank you.
Thank you.
Okay.